All right, today we're pulling back the curtain on the tech that's powering just about everything you see. From ChatGPT to Gemini, we are talking about large language models, and we're going to dig into how they actually work under the hood. You know the feeling, right? You type in a question and boom, a perfectly coherent, sometimes kind of brilliant answer comes back in seconds. What is actually going on in that moment? It really can feel like magic, but I promise you, it's not. It's this fascinating mix of probability, prediction, and some seriously clever engineering.
So how are we going to demystify that magic? Well, we'll break it down into 5 key parts. First, we'll get a handle on what an LLM even is. Then we'll uncover the secret to their speed with this cool idea called the Committee of Experts. After that, we'll look at how an AI literally picks its words, how you can control its creativity, and then we'll wrap it all up with the key takeaways.
Okay, first things first, what are we really talking about when we say large language model? The name itself actually gives away some pretty big clues. So here's the absolute heart of it. At its very core, an LLM is basically a prediction engine. Its main job, its whole purpose, is to look at a string of words, or tokens as it calls them, and just calculate the odds of what the very next word should be. Everything else it does, all that amazing stuff, flows from this one simple-sounding task. So why the large? Well, for starters, there's the model's size. We're talking about hundreds of billions of parameters, and you can just think of each parameter as a tiny little knowledge knob that gets fine-tuned during training. It's the combination of all these knobs that holds everything the model has learned. And the second part of large is the training data. I mean, these models are trained on absolutely colossal data sets. Basically, they read a huge chunk of the internet. We're talking about tens of trillions of words. It's like giving someone a library of every book ever written and just telling them, go find the patterns. And finally, large refers to the sheer, raw computing power you need. Just to train one of these models requires thousands of specialized GPUs, all running nonstop for weeks, sometimes months. It's a huge investment in both hardware and energy. So this brings up a really interesting question. A bit of a paradox, right? If these models have hundreds of billions of these knowledge knobs, how on earth do they respond to you in just a few seconds? Shouldn't it take forever? Well, it turns out modern LLMs have a very clever trick up their sleeve. Just imagine you walk into a room with a mathematician, a chemist, and a historian. If you have a math problem, you're not going to ask all 3 of them for help, right? You'd go straight to the mathematician. This is exactly how this mixture of experts architecture works. A part of the model called a router looks at your question and only activates the most relevant expert, letting the others just sit this one out. And this right here shows the difference perfectly. On the left, you've got the old way, a dense model. It forced every single parameter to fire up for every single word. Imagine asking that whole committee for their opinion on everything. It was incredibly slow and expensive. But this mixture of experts approach on the right, it's a total game changer for efficiency. And here's why this is such a big deal. These so-called experts aren't just random bits of the model. They are the feed-forward networks, which are by far the most computationally demanding, the heaviest part of the whole operation. So by only turning on 1 or 2 of those at a time, you get this massive boost in speed without really sacrificing the model's overall brainpower. Okay, so we've got that the model is both huge and somehow also really efficient. But how does that efficient process actually create the sentences that we read? Let's break that part down. So after all that complex processing, what the model spits out for each step is actually just a simple probability list. It looks at your input, like a cute teddy, and it assigns a probability score to every single word it knows. So here, bear is the most likely next word with a 65% chance. But what happens next? Well, it has 2 main options. The first is called greedy decoding, and it's pretty simple. It just picks the word with the highest score every single time. It's predictable, sure, but it can also lead to really robotic and repetitive text. The second, more common method is called sampling. It basically rolls a weighted die based on these probabilities. Bear is still the most likely to be chosen, but there's a real chance it could pick cat or even car. This right here, this is the secret to the model's creativity. It's why you get a slightly different answer every time you ask the same question. And this brings us to the most powerful tool you have to influence what the AI says. It's a setting called temperature, and you can think of it as your personal creativity knob. When you set a low temperature, you're telling the model to be more confident and way less adventurous. It sharpens these probabilities, making the most likely word even more likely. The whole distribution gets really spiky.
The output becomes more focused, more factual, and way more predictable.
But then you see what happens when you turn that temperature up. It flattens the whole distribution out. The probability of the top word, bear, actually goes down, while the chances for those less likely words like cat and car go up. You're basically increasing the randomness, encouraging the model to take more risks and make more creative, sometimes unexpected connections.
And this is the core concept, put perfectly by the Stanford lecture this explainer is based on. Low temperature gives you a spiky, predictable result. High temperature gives you a uniform, more creative result. It's just one simple dial that has a massive impact on the AI's entire personality. Okay, we have covered a ton of ground, from the deep architecture of these models all the way to how they choose each word. So let's just boil it down and lock in the most important points.
So, 4 key ideas to walk away with. First, at their heart, LLMs are just next word predictors. That's their core function. Second, they get their incredible speed by using that clever mixture of expert system. Third, their creativity isn't magic. It comes from sampling, basically rolling a weighted die to pick the next word. And finally, and this is the most important one for you, you can directly control that creativity using the temperature setting.
Understanding these ideas really moves you from being a passive user to being an active director of the AI. You're no longer just asking questions, you're actually shaping the very nature of the response. So the real question is, with this newfound control, what are you going to create next?